Hello everyone, today in this video we'll be discussing the first module of mechanical super important questions, and in this module all the questions which are repeated from the previous papers and the model paper are discussed. Don't miss any of these questions. If you solve all these questions you can easily score more than 80% marks. So don't miss any of these questions, study this well, and before starting please do like and subscribe. It helps me make more videos like this. And without wasting more time, let's get started. The first question is, explain the role of mechanical engineering in industry and society. Okay, so what does mechanical engineering help us with in the industry and society? Okay, so let's have a look at each point one by one. Mechanical engineering is one of the core branches that plays a crucial role in industrial development. Okay, what all the things required in the industries, the equipments and the instruments, all those things are developed by mechanical engineers. Okay, and those things are utilized by the society for societal progress. It focuses on design, analysis, manufacturing and maintenance of mechanical systems impacting various sectors. So let's discuss the few of the roles in the industry. The first is the manufacturing and production. Okay, so they develop and improve machine and tools automation system used in industries, and they contribute to mass production like the CNC machining, robotics, increasing efficiency and cost reduction. Next is the automotive and transportation. In the transportation, the vehicles all are designed by whom? Mechanical engineers. Okay, and they also work on the electronic vehicles, EVs. Okay, the third one is the energy sector. Okay, in the energy sector, mechanical engineers contribute to the power plants, including thermal, hydro, wind, and solar energy systems. Okay, these are the energy sources from where the energy is obtained. So the mechanical engineers design these systems. Okay, and they optimize the energy conversion storage system, improving efficiency and sustainability. Next one is the aerospace and defense. In the aeroplane, satellites, rockets, all those things. Okay, with the how does aerodynamic works, all those things are studied by mechanical engineers. Next one is the robotics and automation. The design of the robots and how it can be automated, and the integration of AI and IoT, all those things are studied by mechanical engineers. In the construction infrastructures, they contribute to HVAC, which is heating, ventilation and air conditioning system in buildings, and they design the elevators, the escalators and heavy construction machinery for infrastructure development. Okay, and that was about the role in industry. In For the role in society, they design the medical devices which are used in the for the patients, like the prosthetics, implants and robotic assisted surgery tools. Also biomechanical engineering, sustainable development like eco-friendly techniques to how to recycle the waste and use it again, and sustainable development, and improve the fuel efficient engines, green buildings, pollution control systems. Water and sanitation, they design water purification systems and desalination systems, and the disaster management and safety. If any disaster comes, how can it be managed and how can people be rescued, all those techniques and equipments are designed by the mechanical engineers. And advancement in technology includes the nanotechnology, 3D printing, AI based printing, and working on satellites, space exploration. All the things required for these are designed by the mechanical engineers. Okay, that was about the society. Next is explain briefly the emerging trends of mechanical engineering in different sectors. Okay, so mechanical engineering is in vast sectors, very a lot of sectors it's present in. Okay, and they improve the efficiency, safety and environmental sustainability. The first one is in the domain of manufacturing and production. Okay, so the industry 4.0 is there, which is smart manufacturing. It uses AI, big data and IoT for predictive maintenance and real-time monitoring. The smart sensors are used. All those things come under the industry 4.0. Okay, next is 3D printing. 3D printing is the advanced printing where the complex materials can be printed with the least material wastage, and it can be used in automotive, aerospace and medical industries. And next one is in the automotive and transportation, designing the EVs and hybrid technology, the autonomous self-driving cars. In the energy sector, we have the renewable energy sources like from the solar panel, wind turbine, bioenergy, and the solar farms, the solar panels which will be there converting the sunlight to electricity. And energy storage system, how can we store the energy using next gen batteries, hydrogen fuel cells. In the aerospace and defense sectors, it is lightweight materials and aerodynamics, how can the aeroplane be made more faster and lighter. And the space exploration, to design the rockets and what are the engines, needed for taking off that rockets and exploring the space, health and biometrics, the medical robots and prosthetics, and biomedical engineering and smart implants for health innovations, and scanning machines. All those things are designed by the mechanical engineers. And robotics and animation, we have the collaborative robots, AI and machine learning robots. In construction infrastructure, we have sustainable and smart buildings and advanced HVAC and thermal system for keeping the temperature cooler. Okay, so these are the things which are present in the sectors under mechanical engineering. Okay, you can remember any five and right. Next is explain the working of wind power plant, solar power plant, and Hydel power plant. Let's have a look at the first one, which is wind power plant. It converts the kinetic energy of the wind to electrical energy. So the wind power plant will be like this, right? So when the air comes, it will get rotated, and when it gets rotated, electricity can be generated. So it converts the kinetic energy of these blades to the electrical energy. Okay, and the working process is same just as I discussed you. The mechanical energy is converted to electrical energy. Okay, and power is generated and transmitted. So the advantages are it is renewable source of energy and eco-friendly, low maintenance cost, while the disadvantages are wind speed is not constant because the generation of electricity depends on the wind, and high initial investment to manufacture and set it up. Okay, the windmill. Okay, that is a high investment cost. Next is solar power plant. It converts the solar energy to electrical energy. Okay, how it gets converted? Using photovoltaic cells, which convert the light into the form of electricity. Okay, by some semiconductors such as silicon. Silicon undergoes a reaction where the uh, sunlight's energy will be converted to electricity by some reactions using N-type and P-type semiconductor diodes. So the current which you get is in the direct current. It can be converted to alternating current for the use. Okay, so the advantages is that abundant and renewable source of energy. Okay, it is a renewable source of energy as well as low operating cost, high installation cost, and it depends on the sunlight. At night or cloudy days or rainy days, we cannot get that energy from the sunlight. Okay, because it will be no, sun will not be there, right? Sun will be hidden, so we will not be able to get the energy from sun. Okay. Next is Hydel or hydroelectric power plant. It converts potential energy stored in the water to mechanical energy, then into electrical energy. A dam stores water at a height. Okay, that is gravitational potential energy. So when a flow control or turbine rotation happens, what happens because water falling into it, the turbine gets rotated. And when turbine gets rotated, electrical energy will be generated. Okay, electrical energy will be generated. That is the working principle of hydroelectric power plant. The advantages are the renewable and non-polluting, and the reliable and provides consistent power supply, and the initial cost is high. In the construction cost is high and affects the aquatic system and requires large land areas. Okay, moving on, we have the next question, which is write a short note on ozone layer depletion and global warming. Okay, how does global warming happen? The temperature of Earth increases, then global warming happens. And ozone layer is nothing but it is a layer above Earth which will be protecting us from harmful sun rays. Okay, and other chemical and other asteroids and everything. Okay, so this layer is present. Now what's happening is due to human activities, this layer is getting destroyed. Okay, then what will happen? Asteroid will come and hit the earth. Okay, and the harmful sun radiation will come and hit the earth, and then people will become with full of diseases. Okay, so that will happen if ozone layer gets depleted. Now what is an ozone layer? It is made up of O3. Okay, O3, which is oxygen 3 molecules located in the stratosphere around 15 to 35 kilometers from the earth's surface. If this is the earth's surface, 15 or 35 kilometers from that earth's surface is the stratosphere, and ozone layer is located in that. Okay, it plays a crucial role in protecting the life on earth, and majority of sun's harmful ultraviolet rays is blocked there. Okay, now the causes of ozone depletion: chlorofluorocarbons, which is CFCs. This material, when it comes and contacts with the ozone, what happens? Ozone gets vanished. Okay, it gets depleted. Okay, because the ozone depleting chemicals such as halogens, carbons, tetrachloride, methyl chloroform, when released into the atmosphere, rise and reach the stratosphere. And one reaction happens in which O3 becomes O2 plus O. Okay, so O2 oxygen it will become, and O will be roaming somewhere. Okay, so what happens? O3 will no more be there, and harmful sun radiation will come and hit the people. Okay, So the consequences will be increased UV radiation leading to skin cancer, cataracts, weakened immune systems, harmful effects on marine life, and climate change will also happen due to the solar radiation. Okay, preventive measures, like there were some protocols which are going on, Montreal Protocol and research and development to help prevent these kind of things happening. Okay, the ozone depletion. That is about ozone depletion. The global warming refers to long-term increase in the Earth's temperature. Why it happens? It happens because of gases trapped into the Earth. Okay, the accumulation of greenhouse gases in the atmosphere which trap the heat. If heat is trapped into something, what will that become? That will become hot, right? So how does heat get trapped? Okay, first is one, there will be greenhouse gases, right? There will be greenhouses for planting trees. Okay, so trees will be planted inside the greenhouse, and the heat will come inside this, and it cannot escape back. Okay, so if it does not escape back, it will stay inside this, and what happens? It will keep on staying inside this, and this will be rising the temperature inside it, and that will be released to Earth, and it will be staying in the Earth only. Okay, so in that way the global warming will happen, the earth will become more hotter. Okay, so another causes of global warming are the release of carbon dioxide and the methane from emitted agricultural landfills and stocks, nitrogenous oxides, and O2 will be released. Because of that also global warming will happen. Deforestation, the lack of trees will, due to lack of trees, what will happen? CO2 content will increase, and when CO2 will increase, global warming will be increase. Industrial activities that produce several GHGs contributing to the warming effect. Okay, so the what will be the consequences? Melting of polar ice. Okay, what will happen if the polar ice melts? The ocean's level will increase. When ocean's level will increase, at that time some countries will become underwater. Okay, and changes in weather patterns or ocean or acidification because of the industrial acids released directly into the ocean, loss of biodiversity. Many species are facing extinction due to changing habitats and ecosystem. Okay, what are the preventive measures? Preventive measures is to reduce the carbon by using renewable sources of energy like solar, wind, and hydroelectric power. Energy efficiency improvements in the industries, homes, and transportation. Promote reforestation and plant more trees. And international agreements like Paris Agreement, and to aim the limit to the global temperature to rise below 2 degrees. Okay, that is, by these preventive measures we can reduce the impact of global warming. Moving on to the next question, we have explained the following: fossil fuels, nuclear fuels, and biofuels. Okay, fossil fuels means what? Fossil is nothing but dead remains of plants and animals million years ago. Okay, so those are from the plants and animals millions of years ago, pressurized over millions of years, so that it becomes a fuel like coal, oil, and petroleum. Okay, and natural gas, and these are used for driving the vehicles. Okay, it is used for the power generation and transportation, industrial heating, and chemical production, and residential heating. All these things are used. The power is present inside those fossil fuels, and those are generated by the dead remains of plants and animals. Next is the nuclear fuels. Nuclear fuels are materials that can undergo nuclear fission or fusion to release large amount of energy. Okay, the commonly used nuclear fuel is uranium 235 and plutonium 239. Okay, it undergoes fission and in the nuclear reactor to release large amounts of energy. Okay, so what are the applications? Electricity can be generated, medical isotopes can be generated, nuclear propulsion can happen in the rockets and the submarines to make it move forward. Space exploration is possible if the nuclear fuels, it is fueled by nuclear materials that can be used to provide spacecraft into deep space missions. Okay, next is biofuels are produced from the organic materials such as plant, algae, and animal. Okay, common biofuels include ethanol, okay, and biodiesel. The applications: the biofuels can be used for the transportation. They can be an alternative fuel in the cars. Electricity can be generated. It can be used for heating and cooking, for the industrial use, and sustainable aviation fuel. For the aeroplanes also it can be used. That was for the module 1. And moving on to the module 2, we have explained the working principle of lathe with a neat diagram. Okay, so what is lathe? It is nothing but a workpiece held securely in a chuck or between the centers, rotated by a spindle of lathe. Okay, so it is held between a chuck in the centers, and it is rotated by a spindle. Okay, spindle is nothing but a stick. Okay, so it is rotated by that. Okay, So the cutting tool is fed against the rotating workpiece to remove the material, and the cutting tool moves in a linear motion, either horizontally or vertically it can move. Okay, and as the tool moves along the workpiece, the small layers of the material are removed. Okay, so this is the diagram of it. The five things you need to remember is, first is the headstock. Okay, headstock is nothing but it contains the spindle that holds and rotates the workpiece. Okay, so this is the head stock. It contains the spindle that holds and rotates the workpiece. Second is tailstock. Okay, what is tailstock? Tailstock will be supporting the workpiece on the other end if required. Okay, in the other part of the end, if the support is required, that will be present. Okay, third one is bed. What does bed do? It will support the whole thing. Okay, it will support the whole thing, supports the workpiece and the components like a headstock and the tailstock. Okay, and after that is the carriage. Carriage is nothing but it will be helping to hold the tools and move it along the bed, so it is a movable part. Chuck and cross slide are the workpieces during operation for the tools movement and workpiece axis. Okay, so this is the diagram you need to make. Okay, and moving on to the second question, we have explained the working principle of milling and drilling. Okay, what is milling, what is drilling? Milling machine is used for machining flat or irregular surfaces. If there is an irregular surface, if you do the milling, it will become like this. Okay, by the use of rotatory motion of the cutter and linear feeder into the workpiece. Okay, so the working principle is also same. Whatever is the irregular material, that will be present, and miller will be put on top of it, and rotation will happen on top of it, and then it will become a flat surface. Okay, so this is the milling. Here like it will be like this. To make it even, we will be moving it in this direction or in this direction, so that whatever is the extra material present in the top, it will be removed, and it will be a straight line. Okay, so that is a milling machine. The next one is drilling machine. Drilling, what it will do, it will pierce a hole into the wall. Okay, this is a drilling machine, so it will pierce a hole into the wall. Okay, when we drill it, it will be rotating like this and removing all the waste materials, and it will be keeping on going inside and drilling it. Okay, so that is a drilling machine. Okay, this is the diagram you need to make. From here the drilling happens, and here are the spindle and the downfeed handle, and here is for the electrical motor, and here is for the column, and this is the base, and this is the table, and this is for the handle to rotate it. Okay, so these things you need to make. Okay, for the drilling machine. Moving on to the next one, we have, right with the neat sketches, explain the following: boring, reaming, drilling, end milling, and plane milling. Okay, boring means what? Enlarging a hole that has already been drilled or cast. We are making the hole larger. Okay, by again drilling it. That is called as boring. Okay, so this is the workpiece, and this hole was this much only. Then the hole became this much. Okay, that is the boring. And next one is reaming. Reaming means it is a process of finishing a pre-existing hole by using a reamer which remove the small amount of material to improve the size accuracy of the surface, finish the hole. So it will go inside the hole, and it will make the surfaces smoother. Okay, and it will remove the waste materials to get a finer finish. Okay, that is the reamer. Okay, next one is drilling. Drilling we already discussed. It will just drill a hole into the material. And end milling is nothing but it will be having an end here. It will be used to remove the unwanted materials from the end. Okay, next one is the plane milling. It will be used for milling cutter on the flat surfaces. Okay, it will be working on flat surfaces. If this material is present here and I want to do the plane milling on this, so it will be making this finer and smoother. Okay, that is what is called the plane milling. Okay, moving on to the next question, we have discussed the various components of CNC with a neat diagram and list the advantages and applications of CNC. Okay, what is the components of CNC? First is the input devices. Okay, input devices include the USB, Ethernet, and tapes. Okay, and machinery control unit. It is a computer that stores and executes commands. Okay, control loop unit which drives and controls the machine's access. Machine tool. Machine tool is nothing but what is the main tool present inside that intended to perform a specific task. Drive system includes the amplifier circuits, and feedback devices provides the feedback about if it was the expected behavior or not. Display unit will display whatever is happening, the machine status, and allows the operator to verify if the program has shown any warning or not, or malfunctions. Okay, those are the components of CNC. Okay, this is the CNC machine, and these are the components you need to make. Okay, advantages of CNC machines: precision and accuracy. Okay, it are highly precise and accurate, achieves tolerance within micrometers. Automation and productivity: CNC machines can do the automation with minimal human intervention. Complex and versatile machines: these are complex, it performs the complex operations, and versatile means it can perform various different operations. Repeatability: it can be repeated to perform the same task again and again. Flexibility: if you want to change in the design or specification, you can do that. Reduced human error, because human intervention is less, it's only the computer, the error will also be lesser. Safety, the reduced machine reduces the need for manual intervention, making the operation safer. And reduced material waste, CNC optimizes the tools and the path and what it is going to do, so the material wastage will be lesser. Okay, so the applications of CNC is in manufacturing. It can be used in the to mass produce the objects, and the job shops making the parts and components. That's the first use. And second is in aerospace industry, used to produce precise parts like aircraft components, turbine belts, and landing gear. Automobile industry for producing parts like engine components, gearboxes. What are the minimum parts required? All those things will be produced by CNC. Okay, it is also used in the following, like medical equipment, tool and die industry, consumer electronics, woodworking, and metalworking. Okay, all of these, whatever the parts and components is required, that will be generated by the CNC. Moving on to the next question, we have write a short note on 3D printing. Okay, 3D printing is nothing but creating a three-dimensional object from a digital file. There will be a digital file and a program, and we have in the mind to create a digital product. So in 3D digital product, 3D product, in that case, what will happen? It will be printing it one by one. Okay, by layer by layer. First, it will print this layer, then it will print this layer, this layer, this layer, and so on. Okay, so it will be able to print complex things. Okay, it will be able to print complex things that cannot be printed by a manual process. Okay, or traditional method, it will be harder. That thing also it can print. The advantages applications are prototyping, used to create a model of whatever you have imagined, and medical field also it is used to create prosthetics, implants, and bioprinting. And manufacturing can be used to produce complex parts. And education research allows students research to create models for study or experimentation. And consumer goods, it can be used to produce jewelries, to toys, home decor, and those things can be created using 3D printing. Now, what are the advantages? It allows for customization. Whatever the type of device or thing we want, we can be able to produce it. It can produce complex geometries objects which are difficult to produce with traditional manufacturing methods. And rapid prototyping, it speeds up the design process by quickly iterating the prototypes. Limitations are material limitations. Limited range of materials can be compared to the traditional manufacturing. It cannot have a high range temperature, so that the printer will itself melt when it contact, or some other damage can happen. So limited range of materials can be used to print. And speed, it is slower. And surface finish, object may require post processing for a smoother surface. Okay, printer will not make the surface smooth, you have to make the surface smoother. Okay, that was about the module 2. Moving on to the module 3, and the first question, explain the 4-stroke petrol engine and with a neat diagram. Okay, so how does 4-stroke petrol and diesel engine work? First, we'll discuss about the petrol, then we'll discuss about the diesel engine. Okay, and for both, you have to draw a neat sketch and a PV diagram. Okay, PV means pressure volume diagram. So the first thing is, how does the 4-stroke petrol engine work? Is 4 steps will be there: intake, compression, power, and exhaust. Okay, I'll directly show you the diagram so that you'll be able to understand what's actually happening. Okay, theory part, you can go through it. Okay, so intake, what happens? See, the main task is to rotate this. Okay, main task is to rotate this so that in a car wheels will be getting rotated. So for that, what happens is 4 steps are there. First step is, here the air and mixture will be there. Air and fuel mixture will be present. Okay, and what happens here? The compression will happen, means this will go up and it will compress it. Okay, so valves are closed here. Here valves are open and here it will be closed. Now what happens when it is full pressured here? At that time, a spark will be ignited here so that it will produce the gases. And when it produces the gases, it pushes down the piston. And what will happen? Exhaust gas will come out of this. Okay, so one successful rotation will happen. This is one single 4-stroke. Okay, 4 strokes will happen in a single cycle. Okay, so PV diagram is nothing but pressure volume diagram. All you have to do is, you have to make a diagram like this. Okay, just make a diagram like this, and then you have to do some markings. Okay, what will be the markings? First, what is happening? Initially the volume increases because we are getting the fuel and air mixture. Okay, so volume will increase, pressure will remain same. Then what happens? It will get compressed. When it gets compressed, volume reduces and pressure increases, and again pressure increases, and until a spark happens. When spark happens, pressure will decrease and the volume will increase. Okay, and here is the Q out. Okay, so this is the diagram you need to make for the petrol 4-stroke engine. Like that only we have for the 4-stroke diesel engine. Here also it's the same thing, but it is more intense. Okay, here it is more intense. That's all you have to write the difference. Everything will be same. The theory part, you can go through it. Okay, so the graph will be slightly like this because it is just a bit more intense. Initially it was like this in the petrol, but here it is more intense, means more pressure it will increase in diesel. Okay, That is the difference. Okay. Moving on to the next question, we have explained the components of electric and hybrid vehicles. Electric vehicles are the ones which run on electricity. Hybrid vehicles run on both electricity as well as the petrol. Okay, it has both the capabilities. So let's discuss the components of electric vehicle. The main component is electric motor that converts electrical energy into mechanical energy. Okay, and battery pack used to store the battery. It can be ion battery, lithium ion battery, or it can be nickel metal hydride batteries. Capacity is measured in kilowatt hour. Third is the power control unit. It allows the flow of electricity from battery to motor. Okay, and it converts the DC to AC, regulates the voltage for auxiliary systems, and charging system is also present here. This will be present in the fuel stations, where there are three types of charging. Level 1 charging with 120 volts, it is slow charging. Level 2 is with 240 volts, faster charging, and DC fast charging is the fastest one. It uses direct current to charge the battery. Okay. Thermal management system to ensure that battery and motor remain within soft operating temperatures. Safe operating temperatures, preventing overheating and maintaining efficiency is important. Then next is regenerative braking system. What happens when we click brake? When we click brake, the reverse energy happens here. Whatever the energy we are applying, that will be used to stop the car, and some heat will be going wasted. But that heat we can use and store it into the battery so that it will improve the energy efficiency, reusing the same heat. That is called as regenerating braking system. Next is transmission. While many EVs have a single speed transmission, many have multi-speed transmission to optimize at different speeds. So onboard charger converts AC from the charging station to DC to recharge the battery pack. Okay. So basic components of an electric vehicle are follows. Okay, these are the basic components. Here battery tank will be there, onboard charger, power converter. Here will be the motor drive and electric motor drive, and this will be the transmission. This is all basic component of electric vehicle. Next, let's have a look at the hybrid vehicles. In hybrid vehicles, there will be a combustion engine like the normal four-stroke engine, as well as there will be an electric motor. Okay, so internal combustion engine, its function is to convert petrol or diesel to the power vehicle when it is having the battery is low. Okay, and it is more efficiently used in the hybrid vehicles than in the traditional vehicles, and it's optimized for fuel economy. So initially, it will be in the electric only, and whenever we want, we can convert it into the fuel. Okay, so in emergency purposes, it will help. Next is the electric motor. It is a hybrid vehicle supplement the ICE by providing additional power or driving the vehicle electric power for short distances. And regenerative braking is also used in electric motor. Battery pack used to store the energy of the electric motor, smaller than one used in fully electric vehicles, and it is charged to regenerative braking or the ICE. Okay, and power split transmission, the power can be split how much ever the power comes from the motor and how much from the ICE. Based on that, we can seamlessly switch between both of the power sources. Inverter will convert DC from the battery to the AC to power the motor. Energy management system, interaction between the ICE and the electric motor is the energy management system. And fuel tank, it will store the fuel or the petrol or the battery as well. And regenerative braking system, you like in the electric vehicle, the system recovers kinetic energy during braking and sends it to battery for improving performance. Okay, so it uses the whatever the energy that might have got lost, but it has saved it, so it will send it back to the braking and I mean to the battery to improve the efficiency. Okay, so this is the diagram we need to make. Moving on to the third supplement question, we have write down the advantages and disadvantages of hybrid EVs and hybrid vehicles. So advantages of EVs include zero emissions since there is no petrol, lowering operating cost because fuel is costlier and electricity is cheaper, lesser maintenance because only battery needs to be changed, quiet operation. The EVs do not make noises like the petrol vehicles. It is highly efficient. Incentive and tax benefits for EVs is present. Energy independence because it is dependent on the renewable energy, and improved performance. It gives us the better performance. Okay, and disadvantages, the limited range will be there, how much it can travel, charging infrastructure is very rare in the towns, and long charging times, it will take a lot of time to charge, initial cost is high, battery life and replacement cost is also high. Okay, and moving to the hybrid vehicles, the advantage is that better fuel efficiency because we can switch between fuel and electricity, reduced emissions and extended range. It can rely on gasoline engine for long or longer trips, eliminating concern about the range limitations that electrical vehicles face. Okay, so whenever long trip is there, it can switch to the fuels. Okay, and regenerative battery braking is also present here, and no need for external charging. It do not requires external charging infrastructure, as the batteries are charged by the internal combustion engine and the regenerative braking. Okay, so it will be means charged based on internal combustion engine and regenerative braking. Okay, and lower initial cost. The initial cost is lower. The disadvantages includes complexity and maintenance. Okay, it is complex to maintain it, and the initial cost is higher than conventional materials. Battery lifespan is lesser, and replacement might need to be done, and limited electrical only range. Okay, the range is limited only when driving electric, and fuel dependency, it depends on the fuel because it is a hybrid one. Okay, moving on to the next one, we have write down the applications of IC engine, internal combustion engine. Okay, so applications are include in the automobiles. It is used the cars and all. Aviation sector, it is used in the aeroplanes and the aircraft, and in the marine vessels like the ship and the submarines. It is used. Power generation can be used in the power backup systems. Agriculture also, it is used for giving power to tractors, combine harvesters, and plows. And the construction equipment also, it is used like bulldozer, excavators, and cranes. Railways, it is used for traveling, driving the trains, especially in the diesel electric locomotives. And industrial machinery are employed in various industries to provide the compressor, pumps, and mills. All those industrial things, it can be used to power. Okay, the application of IC engine. Okay, these are the applications of IC engine. Moving on to the module 4, we have the first question: differentiate between soldering, brazing, and welding. Okay, so brazing is the least one, soldering is a little better one, and welding is the strongest one. Okay, like that we can remember. So joints are stronger than soldering but weaker than welding. Okay, it produces weakest joints. Okay, so first is soldering weakest, then comes brazing, then comes welding. Okay, this is the strongest one. So this is the in between both of these. This is the weakest. This is the highest. Okay, temperature 1000, temperature 800, temperature 7000 also. Okay, and workpiece is heated below melting point. It is not heated here. It is heated to the melting point. Mechanical properties may show negligible change, no changes, and changes are more here. Okay, and here the cost is between the skills and between the two other methods, and cost involved is in the skill is requirements very low, cost is high here. Okay, no heat treatment in both, but here it will be having heat treatment and unwanted effects of welding. Okay, and it is done at low temperature, it is done before soldering, and this is performed at high temperatures. Okay, so these are the differences. Any five you can remember and write. Okay, next is explain the working of arc welding process with a neat sketch. In arc welding process, what happens, whatever is to be welded means joined, these two metals are there. So what happens, electricity is put here so that it gets melted and it is joined. Okay, that is only the same thing here. You can go through the theory part. So here the whatever is the material is here, the arc it gets put here, and the electrode holder, it will be melting it and it will be joining it. Okay, explain the types of ferrous and non-ferrous materials and list the application of the same. Ferrous materials which contain iron as the main element and are magnetic. Whatever is magnetic, that is the ferrous materials, and types include the carbon steel, alloy steel, cast iron, stainless steel, wrought iron. And non-ferrous materials contain no iron inside that. They are more resistant to corrosion and are not magnetic. So examples include aluminum. It is not ferrous material. Copper is also not ferrous material. It is used to create the circuit boards. Zinc is also not a ferrous material. Lead and nickel is also not a ferrous material. Okay, so the composition properties and applications are there. You can go through the theory part later. But for now, the applications of ferrous and non-ferrous materials. In a ferrous material, what are the applications? Construction and infrastructure, it is used. Steel and iron are used to build structures. Okay, automotive industry, it can be used to create the car body parts and engines and chassis. Next is the machinery and tool to create high strength tensile materials. Alloy steels are used to make tools and machinery parts. Ship building, it can be used to create a ship, and manufacturing household items can also be done using ferrous materials. Non-ferrous materials, it is used in the electronics and electrical. For copper is used in the printing circuit boards due to high electrical conductivity. Aerospace and defense also it can be used due to the lightweight and high strength. And marine industry also, it can be used for ship propellers, material, marine hardware, and heat exchangers. And batteries also, it can be used for the zinc. And the automotive industry also, it is used for automotive parts like engine block, block panel, and wheels. Okay, Next is write down the classification of the welding process and hence explain the gas welding with a neat sketch. Okay. So classification of welding process, it consists of joining two materials. What is welding? Joining two materials using a high temperature, providing a pressure in between them so that it becomes joined. Okay. So based on the heat source, gas welding is present, a flame is produced, arc welding is present, electric arc is produced, and resistance welding uses electrical resistance, and laser welding uses laser beam, and electronic beam uses an electronic beam to provide that. Okay. So based on the type of electrode, consumable electrode welding will be there and non-consumable electrode welding will be there. In consumable, the electrode melts and becomes a part of the weld. In non-consumable, electron does not melt. That's all. Okay, electrode does not melt. Based on the type of filler material, the process requires to a filler to add it to the weld. This will be MIG, TIG, and gas welding. And if it is not requiring any filler material, no filler materials are directly being added. Okay, example, friction welding, it happens without any materials. Okay, so this is the diagram you need to make. Okay, and gas welding, it is a process that uses the flame to produce the combustion of gas. Okay, it uses the flame to produce by the combustion of a fuel gas mixed with oxygen to melt and join the parts. Okay, so working principle is as follows, such as acetylene ignited to produce a high temperature flame mixture. This flame is directed at a workpieces and causing them to heat apart. A metal filler rod, if used, is added to the joint to fill the gap between the workpieces, and once the molten metal solidifies, it forms a strong bond. Okay, so this is how the gas welding works. High temperature is generated using the oxygen and fuel gas, and then whatever is the thing to be joined, that will be joined in the very high temperature, and then it will be left for cooling. Okay, moving on to the next question, we have explain or write a short note on the types of flames. Okay, few types of flames are there when we lit a fire. At that time, first type of flame could be neutral flame. Here the oxygen and acetylene, the ratio will be 1:1. Okay, it is a very stable and symmetrical shape. Temperature is 3200 celsius and small inner core with intense heat surrounded by soft outer envelope. Second is the carburizing frame. Carburizing flame, here the oxygen is little bit lesser, so a flame has inner luminous core, temperature lower than a neutral flame, and inner core of the flame is rich in carbon. Okay, and applications include welding for the high steel carbons, and common processes like hard facing and hard treatment. Advantages: helps prevent the oxygen, as well as metals are prone to oxygen, for materials benefit from the carbon enrichment. Okay, and next is the oxidizing flame. Here the ratio of oxygen is more, so flame is sharp, short inner core with light blue envelope. Temperature is higher than both the previous one which we discussed, neutral and carburizing, and flame is intense. Okay, it is also used for the welding and removing oxides, and the advantages is that you produce the higher temperature. Okay, used for melting higher melting points, and flame hardening process where oxidation is beneficial. Okay, so these are the advantages of the oxidizing flame. Okay, that was for the module 4. Let's move on to module 5. We have first question, which is define mechatronics. Is the differences between open loop and closed loop system. Okay, what is mechatronics? Mechatronics is an interdiscipline field between the mechanical and electrical. So if we combine mechanical and electrical, we'll be getting mechatronics. Okay, this is mainly used in the domain of robots. Okay, for automation and stuff. So difference between the open loop and closed loop system. In open loop system, we do not have a feedback. Whatever is the output we are getting, we are unaware of what is the output. We'll keep on doing the same thing again and again. No feedback is present here. Closed loop system, feedback is constantly provided by the monitor to the exist the closed loop system. So obviously closed loop system is better than the open loop system, and it is less accurate. This is more accurate. This is less reliable. This is more reliable. It cannot adapt. It can adapt. Less expensive and more expensive because it gives better outcomes output. Okay, so this was the differences. Moving on to the second question, we have give the broad classification of robots based on configuration. And the basis of configuration, the first one is the polar configuration, which is spherical configuration. It will be consisting of a rotating base with an arm fixed length and a spherical polar coordinate system for the movement. So it will move based on the system, and it will be having a base with an arm fixed length. Okay, and the components will be rotatory joint, provides the rotational motion, and linear joint, which will provide the linear motion up and down. Okay, and the movement will be up and down and right and left. Application will be for including the spherical workspace, material handling, building, and painting in confined spaces. where the workspace is within a spherical region. Wherever it is a spherical region, it will be working very good here. If there, okay. Next is cylindrical configuration. It's based on cylindrical coordinate system and consists of one rotatory joint and two linear joint. Okay, rotatory joint is how much? One. Linear joint is how much? Two. Okay, up and down, up to down, and rarely in and out. One is up to down, and second is into out. Movement, it can move along the vertical axis, z axis, and radially along the x and y axis. Okay, and applications include, it can be used in assembly, pick and place tasks, and material handling and packaging. Next is Cartesian coordinate robot. In Cartesian coordinate robot, there will be xyz values, which is the orthogonal axes, and movement will be along the xyz, forming a rectangular or Cartesian coordinate system. Okay, so it will be heavily used in the 3D printing, CNC machines, and pick and place operations. Next is the joint arm configuration. In joint arm configuration, it is an articulated robot. It is the most commonly used robot in the industrial application. Consists of a series of rotatory joints, making it flexible and capable of complex movement. Okay, among all the configuration, this is the most important one. Okay, and the most used one. Okay, and the most, I mean, this is the best one. Okay. So rotatory joints, the components are the first one, multiple rotating joints simulate the movement of a human arm or shoulder. Degrees of freedom, number of rotatory joints determine how much flexible it is. The degrees of freedom allow for complex movements. Okay, you can rotate the arm in various directions and perform the tasks, and the applications include welding, painting, packaging, material handling, assembly, and so on. Okay. Next is define automation. What is automation? Automation is automating the task so that the robot will perform the task while human, with the least human intervention. Okay, that is called as automation. The two types are there. First one is fixed or hard automation. In this, the involves the use of specialized equipment to automate a specific task or the operation. The equipment is designed for a particular process. Okay, so this is the fixed or hard automation. Characteristics are inflexible and suitable for mass production, and it is high initial investment cost. Okay, examples are automated assembly lines in car manufacturing, where the production line is dedicated to a particular model. Okay, one particular model it will be dedicated and that will be produced. Okay, that is fixed or hard automation. Second is programmable automation. It can be redefined to program different tasks, and where the products can change frequently, there it will be used. Okay, so the characteristics are flexible and used in industries where products are produced in batches, and suitable for moderate volume production. The third one is flexible automation. It is the advanced version of the programmable automation. Okay, it is more better and of course higher flexibility and more quality and more production requirements and so on. Okay, it can automatically change the product type and operation without significant reconfiguration. So this thing is also automated here. It is product type and operation, it can be taken, and works continuously with a minimal downtime and higher cost, but for wide range of projects it can work, and low to medium production it is supporting. Okay, what are the advantages, applications, and disadvantages of robots? First is, what are the applications of robots? It is used in manufacturing many things. Robots can manufacture many things. It is used in healthcare to perform highly precise and minimal invasive surgeries. Agriculture, it can be used to help water, plant harvest, weed, and monitoring the crops health as well. Next is logistics and warehousing. How and where to get the good from, and where to keep, how to sort it, how to deliver it. All those things robots can be used. Space exploration robot can be used. Military and defense it can be used. And education and research it can be used to provide ample examples and the diagrams for explanation. Okay, and advantages of robot include increased productivity. Robots will not get tired like humans, and precision accuracy will be more than humans. Safety in hazardous environments. If robots are working, they can be used in dangerous environments also, because it will not affect the robots. We humans, it will get affected because inside us blood is there. And reduced labor cost. The robots labor cost will not be there. It will not ask for the salary. And improved consistency. Robot will give us more consistent deliveries of the operation what is to be performed. Disadvantage is, it is high initial cost and job displacement can happen, and many people will lose the job. Lack of flexibility in handling complex tasks. The robots cannot handle complex tasks unless it is trained on that. Fourth is the maintenance and report cost is higher. Dependence on software and programming. It depends on the software and programming how it is present. Okay, moving on to the fifth super important question we have. Explain the following characteristics of IoT, logical design of IoT, and communication models with respect to IoT. So the characteristics of IoT are: first is connectivity. The IoT devices can connect with other older devices. Automation and control will be there. Automatically it will do the tasks, and control also will be in our hand, what we want to automate and what we do not want to automate. Data collection analysis, a lot of generic data can be generated that can be used for various purposes. It can be scalable, and interoperability can operate within different devices, and real-time communication can happen. It is secure as well. Okay, security is also maintained here. Okay, next is remote monitoring and control. In this, IoT allows for the monitoring and control of devices anywhere from the world using smartphone, telephone, or tables, tablets, or computers. Okay, so this is the logical design of IoT. The third question: application is here and device is here. In between, we have the management, security, services, and communication. Okay, so data collection processing. IoT is collect the data from the sensor, and then it will be processed accordingly, and find out what are the insights we have got from it. Okay, and cloud infrastructure, it is used to store, access, and process the data. Analytics and insights will be generated by the feedbacks, and integration with the other systems. IoT can integrate with the other systems as well, like ERP, CRM, and other business applications. User interface is good for configuring, monitoring, and controlling devices. Communication models with respect to IoT. Okay, so there are few models present: client, server, and resources are present here. So basic model is the client server model, which is device to device. Okay, device communicate without intermediary using real-time application like industrial automation or smart home. Device to cloud, the device send the data to the cloud, from the cloud the response come back. Okay, and cloud to device, cloud will request or update the update to devices typically used for the firmware updates or remote control devices. And cloud to cloud, the communication happens between the different clouds used for the cross platform integration or data sharing between the clouds. And next is peer to peer. It can be a decentralized work used for the decentralized apps in the blockchain systems, and it will be between peer to peer communication. Okay, that's all for the video. All the best for your exams, and please like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.